people interested in coding and taught basic programming skills. We also gave our students a chance to lead this week. Every student gave a 5-minute lightning talk about a technology topic in the news. We worked on data structures, time complexity, and sorting algorithms. The students also completed their first solo project.
Well, what Connie didn't tell you was that it was his birthday.
access things inside the function by using this keyword. But if you are used to a more object-oriented programming language like Java, then the way that, maybe it's itself in Java, the way that that keyword works and this keyword work are very different. So it's easy to make mistakes when you use JavaScript. It was a lot, but it's not too difficult. A lot of programmers make mistakes with this, but it's just from never finding out how it works. So, thank you for coming. Let's find out how it works. So, I have a question for everyone. Please raise your hand. Do you like this? Great. Okay, another question. Do you like this? No, me neither. So I asked the same question. Do you like this? Do you like this? The meaning was different. The first one was, do you like chocolate? The second one was, do you like being pushed into a train? Why is it different? The English was exactly the same both times. So why did the meaning change? How did you know the meaning would change?
There was additional information.
The picture told you what this was going to be. The context of the question told you what this was going to be. So to figure out this, we have to figure out context. So, how doesn't this work? There are two traps that programmers often fall into when they are using this. And so I want to see if you will fall into the same traps. So be careful. And don't feel too bad if you do fall in, because even 10, 20 years experienced programmers make these mistakes. So, here we go. Oh, and please be my console.log for this. Write what you think will be logged on the whiteboard. Please try to avoid typing it into your computer and executing it. We'll give you the answer if you do that, but you won't type it. So try to avoid that temptation if you can. Okay, so let's consider this function called count. What it does is it adds 1 to this dot total every time we invoke it. We're going to start by setting count.total equal to 0. Then we're going to call count. We're going to call count again. And then we're going to console log count.total. So what do you think will be logged when we console log count.total? Write it on your whiteboard. Okay, what have you got? Show me your whiteboards. Undefined in the back. We've got a 2 here, undefined in the front, and a 0 in the back there. Answer is... Yes, there we go. The answer is 0. Let me explain why. We create a function. It's going to add 1 to this dot total every time we call it. We set count.total to be 0. So we console log the total. When we call it, this is not the function. Regular function expression. Total. Then we'll try to add something to it. When we console log count.total, we get this 0 back that we set in the first place. It hasn't been touched by the function itself. define that now. The function beta console logs this dot a, and then finally we'll call alpha. So we call alpha, which makes a equal to 1 and calls. Write it down. The reason this time we call alpha, a is set to 1, we call beta, we console log this dot a. What is this in this case? Again, these are both regular function expressions. This remains the global object. There is no this dot a on the global object, so this time we get undefined. Actually, it would probably throw you an error because you're trying to access. We find it to be undefined. So this is not the current scope. That's the other trick, the other trap that veteran developers often fall into. This is not the current scope. Yes, I told you what this isn't. What on earth? To understand this, first we have to understand the call site. The call site is the place where the function is called. Simple as that. When the function is called, that's when we assign this. Understand the call site, then we can understand this. So we've got function footer calls PO, function PO calls Hoge, function Hoge console logs the string Hoge, and we start by calling Kuga. In case you're wondering, this is Fubabas in Japanese. What is the call stack? We start with main. We're going to have up. Can you write on your whiteboard? Call stack. Each function is bound to this. It might be different, but it's bound to some this every time it is called. How do we figure out what this is going to be? Well, there are just 4 simple rules. Let's explore those rules together. They are the binding rules. Binding is just the act of taking a function, taking a this, and sticking them together, binding them. There are 4 rules to determine what this is going to be. Default binding, implicit binding, explicit binding, and new binding. So let's go through those one by one and talk about what each one means and how each one works. So default binding. You'll avoid those problems as well. Okay. Implicit binding. What does that mean? That means when we call a method from a property. So we've got the same function again. Console log this.a. We've got an object. that you want the function to have. The only difference between call and apply is that these are passed in 1, 2, 3, 4, 5 individually, and these are passed in an array. Other than that, there's really no difference between them. Bind is a little different. I'll talk about bind in a moment. All you pass to bind is the object that you want to set to this. So, bearing that in mind, we've got a function called spam, which console logs this.a. We've got an object with a set to 2, and we're going to use spam.call, passing in object. So what is going to be console logged? Write it down.
So call. It's a method. It's not a function. Call the keys and target context. So one is calling the functions. The const is the
Okay, what do we think? Let's take a look at your whiteboards. Error 2. What do you think, guys? Not sure? 2. The answer is 2. The answer is 2. The way that this works, as I said, call is available on every function that you make. It takes in some object. It says, when you do your stuff, this is going to be whatever I give you here. So when we get to this line, this.a, this is the object that we passed in to call. So this.a is going to be 2. With explicit binding, we're trying to make it clear what this is going to be. As I said earlier, we could have used apply as well. They are essentially the same thing. The difference is how you pass in the other arguments. Because we have no other arguments here, it doesn't matter which one you use. We can also use these to fix the problem that I had earlier, which is losing the context. So can you figure out, how do I fix line 8 so that line 9 will work as I intended to? How do we change line 8 so when I call line 9 I get, hello, I'm Alex? Okay, take a few moments to think about it and write it down. I made a spelling mistake. Excuse me. Please change line 9. Don't change line 8. That's my mistake. Change line 9.
change line.
So what have we got? Let's take a look. We got say hello Alex.call me. Say hello Alex.call me. Say hello Alex.call me. Say hello Alex.apply me. Is that right? me.sayhello.applyme. That's
Sure.
close.
Sure.
We have, yes, sayhello alex.call me.applyme would be okay as well. I'm sorry for misleading, it's line 9 that we need to change. I'm getting ahead of myself because changing line 8 is the next part. Say hello Alex kind of implies that every time we call it, it's going to say, hello, I'm Alex. It's going to log, hello, I'm Alex. So we can use function.bind to fix this. So every time we call say hello Alex, it will log, hello, I'm Alex. And that's where we change line 8. If we bind me to say hello Alex, every time we call say hello Alex, it will log, hello, I'm Alex. Even if we pass it somewhere else, if we put it inside a different object, anywhere we call it, this has been bound to the function and it will never change after this line. So, that's explicit binding. The last binding rule is new binding. This is where we use the new keyword to instantiate, to make a new object. This will work with any function, and let me explain very quickly how it works. When you use the new keyword on a function, a brand new object is created from thin air, out of nowhere. You get a brand new object, totally empty, totally new. The newly created object is prototype linked. You don't have to worry about what that means just now. That's a different readup altogether. But that's step 2. Step 3, the newly created object is set as the this binding for that function call, which essentially means the object that I pass back, the this for things inside the object will be that object. You'll see in a second when I show you an example. And finally, the new invoke function automatically returns the newly created object. It's really convenient. Let me show you some code to make that a little clearer. So I've got a function. This time it's called person. It takes a name and an age. It sets this.name to be name. It sets this.age to be age. It sets this.sayhello to console log. Hi, I'm this.name. So what I've done here, I've got a new variable called me. With the new keyword, I call this function, pass in Alex, and pass in the number 28. And then I call me.sayhello. Now remembering those 4 steps, we create a brand new object. We do something with the prototype, let's not worry about that. We set the this for this function call to be the new object that we made. And then we step through this function. So that new object, .name becomes name, .age becomes age, .sayhello becomes this function. So, what happens on line 10 when I call sayhello? What are we going to log? Again, just this .name is plenty. It's too much pressure. All right, what have we got? I'm Alex, 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 Alex. Yes, 4 points all around this time. Well done. No tricks. As I said, we create a new object. This is set to the object. We do something with the prototype. And then we run through the function. And then we return the object. So we get a new object in me with this.name is Alex, this.age is 28, this.sayhello is this function. And then when we call it, we use implicit binding, and this.name becomes my name. Simple. Okay, so binding rules one more time. Default binding when there's nothing else in Fluid. Yes.
Yeah, can I take a question? I thought this word, this keyword,
Yes.
was in the scope of the function. In the previous slide, you had like, right, so you got this dot name and then this dot age equals age.
Yes.
And I thought this wasn't the scope of the function, so how would this dot name be Alex? I mean, does it ignore this dot name?
That's a great question. So, after we've done all this fancy stuff with the new binding, we get an object back. And that object contains these three things. This dot name is Alex, this dot age is 28, this dot say hello is this function. Yeah? Then when we call the say hello method, we use implicit binding to figure out what this is going to be. Because say hello is a method on the me object, the me object becomes this when we call say hello.
No.
So the new binding is useful to figure out what's going on in this line, but in this line it's just simply implicit binding that we looked at before. Is that a little clearer?
Yeah.
Great. So we've got the four binding rules that I talked about. Default binding, where we just have a function called in the global scope. Implicit binding, where we call a function as a property on an object, like this. Explicit binding, where we explicitly say, I want this to be the object that I'm giving to you. And new binding, where we use the new keyword to create a new object from a function. Oh, that was a lot. So we now know the rules to figure out this, but we don't know the order in which to apply these rules. If there are two things going on at the same time, which one is more powerful, if you like? Which is kind of what your question was. So let's talk about that a little bit. So this is maybe the riskiest part of my presentation. I'm going to do some coding, but I still want you to be my console. So let's take a look. Oops, if I throw this over here, I've got this called Quokka installed in my Visual Studio Code, and it is a JavaScript interpreter, and it will give me kind of the console log in real time, so I don't have to run anything, I don't have to compile anything. We've got welcome to the meeting right here. In fact, if I call farewell instead, oh no, I'll have to rewrite the function. Let's not worry about that. Cool. So let's write some code. I'm going to make a function, call it foo, and I'm going to, inside the function, console.log this.a, just like we've been doing all along. I'm going to create a new object. Whoops. Let's not use that. Let's use the next one. Object 1. Set a to be 1. And set foo to be foo. Let's see. Missed equal sign out there. Foo is foo. And we've got another object. Object 2. Set a to be 2 this time, and again foo is foo. So we've got two objects, two different a's, and we've got the same function inside each object. So what I'm wondering is, which one is more powerful? Implicit binding, where we call the function as a method on an object, or explicit binding, where we tell the function what it should use for this. I'm going to zoom out a little bit so we've got a little more space. Let's start with something simple. Implicit binding, object1.foo. In fact, I'm going to say object1.foo. What's going to be console log when I call this? Write it on your whiteboard.
Is it being called?
And if I call it, then you'll get the answer. So please think about it before I call it. After I call it, then I will display the answer.
Does it mean should they treat it as it is?
Yes. So after I call it, what will be logged?
Yeah, it's in the jungle.
Okay, what do we think? Let's take a look. We got 1, 1, 1, 1. Wonderful. We get a 1 up at the top next to the console log. And just for completeness sake, object2.foo is going to give us 2. Great. Now, my question really is explicit binding or implicit binding more powerful? So let's find out. Object1.foo.call. What I'm going to do here is I'm going to pass in object2. So what do you think is going to be console log when I pass in object2? Okay, what do we think? 2, 2, 2. I saw the 2 before. Let's find out. If I pass in object2, we do indeed get 2. So well done. And just for completeness sake, object2.foo.call passing in object1 will give us 1. So as I said, it's not where the function is defined, but where we call it that makes the difference. So explicit binding takes precedence over implicit binding. Okay, next. Let's figure out where new binding fits into all of this. So let's make a new function. Foo. This time I'm going to take in an argument, just something. Anything is okay. And I'm going to set, whoops, get it spell right. I'm going to set this dot a to be something. Then we're going to create a couple of objects, just like what before. Object 1 contains this function, and object 2 is simply empty. So what we're going to do first is nice and simple. Object 1 dot foo passing in 2. Then we're going to console log. We're going to console log object1 dot a. So what are we going to get when we console log object1 dot a? Take a second to think about it. It's a little complicated. When we call object1.foo passing in 2, this dot a will be set to equal 2. So when we console log object1.a, what are we going to get?
You're about to put object1.a in those parentheses.
Yes, I am.
Okay.
Okay, what have we got? We've got 2, 2, undefined, and 2. Let's find out. Object1.a. 2. Well done if you got it right. So we call object1.foo passing in 2 on line 11. On line 11, this is object1. So we set this dot a equal to 2. And then on line 12, when we console log it, we find out that it is indeed 2.
Now let's do something a little more interesting. Object 1 dot foo dot call, and I'm going to pass in object 2 and the number 3. So when I call console.log object 2.a, what am I going to find? Take a moment to think about it. So what have we got? We've got a 3, undefined, 3, and can you take a guess? We'll say that's undefined. Well, let's find out. I'm going to say object 2.a. It is indeed 3. Let me step through why that is. So on line 14 here, we start with object 1. We go to object 1, we say, give me the function that you have called foo. We're going to take that function, we're going to call the function, but we're going to set this to be object 2. I'm going to pass in 3 as the something. So the function foo gets executed. This.a, in this case object 2.a, is set to be equal to 3. And then on the next line when I console log it, I find that has indeed happened. It's a little complicated, but hopefully it's not tricky. Now, where does new fit into all of this? Does new trump implicit binding? Let's find out. Let's make a new variable, bar. I'm going to say new object 1.foo, passing in the number 4. So let's do the most straightforward one first. Let's console.log bar.a. Bar.a. What do you think is going to happen when we console log bar.a?
Yeah. You want to write that down?
All right, what have we got? We got a 4, a 4, a 4, and Tony Stark's nanotech suit equals new. And a 4. And a 4, you didn't get it. I won't leave that out. So bar.a is indeed 4. So what happened on line 17? We used the new keyword, we created a new object out of nowhere. We set this to be the new object, so this.a becomes the new object.a, which becomes 4. So the final question for this little exercise, console.log object1.a. The question really here is, did a change on line 17 in object 1? What do you think?
Object1.a.
Yes, I'm about to console log object1.a. So what do we think? What is object1.a going to be? 2, 2, 2. Do you need a moment? Or? That's alright. Okay, well, let's find out. Object1.a is 2. Well done if you said 2. So the lesson here is on line 17, when we use the new keyword, when object1.foo is being executed, this is the new object, not object1. That's the takeaway from line 19. All right, the last question is, what about new binding versus explicit binding? So let's wind it back a little bit. We've still got our function foo, which will take in something and define this.a to be something. Let's say const object1 is an empty object. And let's say bar is foo.bind, passing in object1. Now we're going to say, we're going to call bar, passing in the argument 2. And I'm going to console.log object1.a. That was quite a lot, so I'll talk about it one more time. New object 1, which is empty. I'm going to create a new function, bar, which is foo.bind object1. I'm going to call bar 2, and I'm going to console log object1.a. So what do you think I'm going to get when I console log? So the question really boils down to, on line 8, what is this?
That's definitely it.
Okay, what have we got? 2, 2, 2. Undefined. All right, let's find out. Let's pass in object1.a. 2 is indeed the right answer. The reason this time, on line 7, we copy the foo function. We bind object1 to the foo to the bar function. Every time we call bar, this is going to be object1, no matter where or how we call bar. So when we call bar on line 8, this is object1. So this.a is object1.a, which becomes 2. So we're almost there. Let's go here. Make a new constant, baz. We're going to use the new keyword this time, but we're going to use our bound function, bar. So what's going to happen here? We've got two rules in play. Explicit binding, where bar is fixed to object1 and can never be changed. And we've got new binding, where we create a new empty object, and when bar is executed, this becomes the empty object. So we're going to console log baz.a. Whoops. What do you think we're going to get? Take a moment.
So is it two questions now?
They're kind of linked.
Oh.
But yeah, concentrate on the first one. Yeah, excuse me. So it's kind of a gamble. Which one is going to take precedence? What do you think we're going to get for baz.a? Let's take a look. 3, 3, 2, 3. Let's find out. Baz.a is 3. So new binding takes precedence over explicit binding. Now my last little brain teaser. What about object1.a? We've called bar, which was bound to object1, but with the new keyword, it seems to have been bound to a new object. So my question is, has object1.a also changed? What do you think? What is object1.a? Okay, what do we think? 2, 3, 3. Oh, 3 and 2. Let's find out. Oops. Object1.a is 2. Well done if you said 2. So when we call with the new keyword, this does indeed change, even if we have explicitly bound it. So now we have the ordering for our binding rules. They are as follows. If you ever need to know what this is, what's the function called with new? In that case, new binding takes precedence. This is the new object that we are creating. Next, explicit binding. Is the function being called with call or apply, or has it previously been called with bind? In that case, explicit binding. Next, implicit binding. Is the function called with a context? Is it object.function? In that case, the object that the function is living in is this. And finally, if none of those rules apply, then it's simply default binding. So that's all there is to it. Now you know how to figure out what this is. Except there is a small asterisk. There is a spanner in the works. There is one more kind of function that we haven't talked about. So in 2015, the JavaScript specification was updated to include a new type of function, what we call an arrow function. And they don't play by the rules. They have their own rule book. So there's not a lot to it. It won't take too long, but I'll quickly go over what an arrow function does. So in this case, we have a function called foo, which returns an arrow function, which will console log this.a. We've got two objects, Object 1, A is 1. Object 2, A is 2. We create a new function by calling foo and passing in object 1 as this, which will return this arrow function. So then the arrow function that's now inside bar, we're going to call, but this time passing in object 2 as this. It's very complicated. I'll say it one more time. We've got a function here which returns an arrow function. We've got two objects. Object 1, A is 1. Object 2, A is 2. First, we call this function here with object 1 as this. That's going to return this arrow function. This arrow function is now living inside bar. And we're going to use .call again to call the arrow function, but passing in object 2 as this. So my question is, what are we going to log? It's going to be 1 or 2. What do you think?
You can match your answer.
The question you have to ask yourself is this a double log? Alright, do we all have an answer? What do we think? 2, 1.
Maybe undefined. Maybe not.
1,
Let's go with undefined.
2, or undefined.
Let's go undefined. See what happens.
Oh, the wild card. Let's find out. 1 is the right answer. Let me explain why. The way that arrow functions work is different from the way a regular function works. This is not defined when you call it. For an arrow function, this is defined when you create it. That's the difference. That's what lexical this is. When you create the function, this is set. So in this case, we got these two objects. We call foo, passing in object 1. At this point, this is set for the arrow function. It's never going to change. When we call the function with this object 2, this is simply ignored. The arrow functions, this has already been set. It's like calling a bound function. It simply doesn't do anything. So when we call the arrow function, we get a 1. Why is this useful? It's useful in the set timeout case that I explained before. If we pass in an arrow function that has the appropriate this, when the set timeout fires, then we'll get what we expect. So in this case, we've got a function which will call set timeout, console logging this.a after 100 milliseconds. If you remember before, if we use the regular function here, it would lose the this binding. But in this case, when we call foo passing in our object, this is set for the arrow function and it will never forget what this is. So when it's called after 100 milliseconds, we get the answer that we would expect to get. So that brings me to the end. One more time to recap. 4 rules. If it's called with new, then it's the new object that you're making that is this. Otherwise, if it's called with call or apply or bind, then it's the object that we're passing in. It's whatever you want it to be. Otherwise, if it's called with a context object, like object dot function, then it's that object preceding that becomes this when the function is executed. Otherwise, you get default binding, which hopefully will be undefined if you're using the strict mode, but it will be with global object if you're not. That's a little thing to watch out for. And if it's an arrow function, that simply doesn't apply. You have to figure out which rule is in play kind of one step before to figure out what this is when the arrow function is actually created. So that's it from me. Thank you very much for your patience. It's been a little bit over an hour. I hope you've had fun. I hope you've learned something. And yeah, thank you very much. This is a link to the slides that I've showed you today if you want to have a reference to it. And this is my GitHub. Thank you. Oh, does anyone have any questions?
Yeah. When using objects within objects, okay, so how would you reference the parent this? So say I have a
it's like the nested
yeah,
function that I had before with object1 dot object2 dot whatever.
So okay, so if you want to come around here, I've got an example. Just for example's sake, it's probably easier just to show that.
Yeah.
Okay, so we got initial function. I'm using var.